Case number 59 in geometry. Let's see, we're told that the circle O, so O is the center, EX is tangent, so since it's tangent, we know that it's perpendicular to the radius there. OE, which is this entire length, is 20, and XE is 15. So XE is 15, OE is 20. What is the area of the circle? So to find the area of the circle, we're going to find the radius of the circle. The radius of the circle is XO, which is the third side of this right triangle, where EO is the hypotenuse. So we have 15 squared plus XO squared equals 20 squared. So 225 plus XO squared equals 400. So XO squared equals 400 minus 225. So pull up the calculator and do that. Just double check. 15 squared is 225. Okay, so we have 400 minus 225, which is 175. The square root of that is 13. Actually, I'm going to leave XO as the square root of 175, because XO is the radius. Because when we find the area, it's pi r squared, so we're just squaring this again, so it's going to be 175 pi. Okay, next we want to find what is the area of the sector bounded by XO and ON. So to find that, we're going to find the angle in there. If we can figure out the angle is, we know what fraction of the area it is. So to find that angle, I'm going to do some trig in this right triangle. Let's just do inverse sine here. So we want the inverse sine of the opposite divided by hypotenuse, which is 15 divided by 20. So go back to the calculator. If I can find the cursor. Okay. So 15 divided by 20. 0.75, and we're going to take the inverse sine of that, so 48.6 degrees. So then we're going to take 48.6 3/60ths of 175 pi. So let's see what that is. 48.6 3/60ths times 175 times pi. So 74.22 is the area of that sector. And the last thing is find the area of the region bounded by XE, NE, and NX. So I was looking at this portion out here, which is basically the triangle minus the sector. So we're just going to find the area of this triangle and then subtract that sector. The area of the triangle is going to be 1/2 base times the height. These are perpendicular, so 15 times, and XO was the square root of 175. So we're going to do 1/2 times 15 times the square root of 175. So 1/2 times, actually I'm going to do the square root of 175 first. So square root of 175 times 15 divided by 2. That's 99.2156. Then we're going to subtract 74.22, which is the area of the sector. So the triangle minus the sector is, looks like just about 25. Okay, so we used the right triangle to find the radius XO. We used area equals pi r squared to find the area of the circle. We then took a fraction of the area of the circle to find the sector. To find out what fraction that was, we had to find the angle. So since this was a right triangle, we used some right triangle trig, used inverse trig to find the angle. It's a fraction of 360 times the area. And then to find this exterior portion here, we took the area of the right triangle, 1/2 base times height, minus the sector which we just found, and find what was on the other side. Any questions or comments about how we set any of that up? Feel free to leave.